Hello, ladies and gentlemen. Today we're going to look at multiple angles, double angles, and power reducing formulas. All right, let's start with the double angle identities. The sine of 2 theta is 2 times the sine of theta times the cosine of theta. The tangent of 2 theta is 2 times the tangent of theta divided by 1 minus the tangent squared of theta. And the cosine of 2 theta has 3 separate formulas. You can use the cosine squared of theta minus the sine squared of theta, or you could use 2 times the cosine squared of theta minus 1, or 1 minus 2 times the sine squared of theta. And those all come from substituting this, the identities that you know into that first formula. Okay? All right, let's start with example number 1. Example number 1 says draw the triangle given the tangent of theta is 8/15 and theta lies within pi and 3 pi over 2. Well, basically what that means to me is I'm going to sketch it first of all, and if theta lies between pi, which is over here, and 3 pi over 2, that means this angle is down here in the third quadrant somewhere. So I'm going to draw me a right triangle down there, okay? And I'm going to let that reference angle there be theta. All right, and I know the tangent, which is the opposite leg divided by the adjacent leg, all right, is 8/15, and I remember that Pythagorean triple as well. Many of you don't, but if you don't, you just have to do your Pythagorean theorem. That is the old 8/15/17, okay? So 8/15/17, and now I've got the angle, all right? And next, part B says to find the sine of 2 theta. Well, the sine of 2 theta, as it says right here, is 2 times the sine of theta times the cosine of theta. So I need the sine and the cosine in order to find the sine of 2 theta. Okay, so I'm going to come back over here, and I'm going to find the sine and the cosine of theta. Let's start with the sine. The sine is negative in the third quadrant, and it's the opposite leg, 8, all right, divided by the hypotenuse, 17. So negative 8/17 is the sine. The cosine is also negative, because that's x, coordinate's negative there, okay, in the third quadrant. So it's negative, and it's the adjacent leg, 15, divided by the hypotenuse, 17. So there's your sine and your cosine. Now we'll bring those over and we'll put them in. So 2 times the sine, which is negative 8/17, times the cosine, which is negative 15/17. All right. Well, the negative times the negative is a positive, times this positive is a positive, so you don't need to worry about any signs, it's all positive. And I don't see any common factors, all right, among any numerators and denominators, so I'll just go ahead and multiply the numerators. 2 times 15 is 30, and 8 times 30 is 240, divided by 17 squared, which, by the way, is 289. Now, I want you to know that you could check that with your calculator, all right? By the way, I don't see any degree symbols, so I'm going to turn my calculator on, make sure that I'm in degree mode, all right, or actually radian mode, excuse me, which I am, okay? And what I'm going to do is I'm going to go in, well, I don't know, we better not check this with the calculator, because if we do that, we have to be very careful about where the inverse sine and cosine is defined. All right, well, we can do it. I'll do it. I'll check it with you. Okay. All right. I know this quadrant is in the third quadrant, and if I do the inverse tangent of 8 divided by 15, that tangent is just going to give me an angle in the first or the fourth quadrant. This angle is not in the fourth quadrant. So in order to get that angle, and by the way, if I were to extend this to it, that angle and that angle are basically the same angle measures. All right, this one's in the first quadrant, that one's in the third. The inverse tangent gave me theta prime, that other angle there. So what I'm going to do to change that to theta is I'm going to add pi to it, because from here, that 0.48 is that angle. I'm going to add that much right there, which is pi to it. So I'm going to do plus pi. And that will give me my theta. There's my theta. I'm going to store that in alpha A. Okay? All right, so now I can go over here and I'll say, okay, let me go and find the sine of 2a. All right, when I do, there it is right there. That is the same thing as 240 divided by 289, as you can see. All right, so that's how you could check that with your calculator. Let's go to part C. Part C asks you to find the cosine of 2 theta. Well, you can do whichever one of those you want, okay? I would probably prefer that last one if you want. You can do it. I'll do the last one. That's what I'm going to do. I'm going to do 1 minus 2 times the sine squared of theta. All right. So that would be equal to 1 minus 2 times the sine squared. The sine itself is negative 8/17. So that would be 1 minus 2 times. A negative times a negative is a positive. 8 squared is 64. 17 squared is 289. All right. So that would be equal to 1 minus 2 times 64 is 128 divided by 289. Imagine this being 289 over 289 minus 128 over 289. Oops, that's an 8. All right, and that would give us 161 over 289. All right, and now that I've still got theta in here, I could just type in the cosine of 2 alpha. All right, and that is this value right here. That should be the same thing as 161 divided by 289. And if you hit math enter, you'll see that it is. All right, let's go do the tangent of 2 theta. All right, the tangent of 2 theta is 2 times the tangent of theta divided by 1 minus the tangent squared of theta. That's the identity. Okay, all right, so we're going to use that identity, and we'll do 2 times the tangent. They gave us the tangent, 8/15. All right, divided by 1 minus 8/15 is the tangent squared. All right, so this would be equal to 2. Oh, wait a minute, 16. Let's just go ahead and multiply. 2 over 1 times, that's 16/15. So 16/15 divided by 1 minus 64 over 225. All right, imagine this being 225 over 225. So then I could combine those two fractions into one and get 16/15 divided by, okay, let's see. If I take subtract this from this, that would be 1 ending with a 1, 161. That would be 161 over 225. All right. And then what I would be able to do is, that's a complex fraction, one fraction divided by another. That's the fraction from the numerator times the reciprocal of the fraction in the denominator. I notice that 15 goes one time here and 15 times there. Okay. All right, I can't reduce anything else, so I'm just going to multiply. 15 times 215 is 240, I do believe. All right, so that's 240 for the numerator and 161 for the denominator. And there is your exact value. Now, since I have the angle theta still in here, I can just type in the tangent of 2 theta. Uh-oh, hold on, that's not 2. Okay, the tangent of 2 theta, get that value, and then hit math, enter, enter, and that should give me 240 over 161. And it did, as you can see. Okay, let's go to problem number 2. Problem number 2 says find the exact values of the cosine of 2x minus the cosine of x equals 0 over the interval from 0 to 2 pi, including the 0 but not the 2 pi. Okay, well, let's use our double angle identity. That's what this is right here for the cosine. And what I'd like would be one that just has cosine in it. And the one that does is that one in the middle up there. The cosine of 2 theta is 2 times the cosine squared of theta minus 1. So I'll replace this using that particular double angle formula. So 2 times the cosine squared of theta, or x, all right, minus 1. And then minus that other cosine of x, and that still has to equal 0. All right. Now, that, guys, is basically a quadratic equation. I'm going to put it in decreasing degree order form so you can see that, okay? And then I'm going to try to factor it, all right? Anytime I have a quadratic, I'm going to try to factor it, okay? To factor this quadratic term, you would need to factor it as to 2 times the cosine of x times the cosine of x. To get a 1, you would do 1 times 1, and the signs have to be different to get a negative, and we want the bigger product, which would come from this outer product, to have that sign, so the negative goes here and the positive goes there. So put 2 times the cosine of x plus 1 times the cosine of x minus 1 is what that expression is equal to. And if that's equal to 0, you take each factor and set them equal to 0. So 2 times the cosine of x plus 1 equals 0, and the cosine of x minus 1 could equal 0. So this would give us the cosine of x is equal to negative 1/2. This would give us the cosine of x is equal to 1. Okay. All right, and now on the unit circle, we'll go and find where is the cosine equal to either 1, it's 1 at 0, okay, or negative 1/2. It's 1 at 0, and that's the smallest one we're going to get in that interval anyway, so I'll go ahead and write it down. And then where is the cosine equal to negative 1/2? Well, that occurs in the second quadrant and in the fourth quadrant. In the second quadrant, it is 2 pi over 3. And then in the third quadrant, it is 4 pi over 3. And there are your solutions. And when you can check that, I will show you. You can check it like this. If you were to make sure you're in radian mode, which I am, okay, all right, you could check it by just saying, okay, I'm going to first of all store 0 in alpha. So 0 store, and I'm going to put it in x, okay? All right, and if I were to go into the original equation, all right, and type in the cosine of 2x, close that off before I decrease that by the cosine of x, okay, and close that off, I should get 0, did I? And I did, okay? If I were to take 2 pi divided by 3, which is that decimal right there, and store that in for x, okay, then I could pull that equation back up, okay, I'll hold on, I don't need that. There's that equation again. I should get 0 again, and I did, okay? Or if I type in 4 pi divided by 3, store that in for x, all right, and then pull that expression back up again, or that whole left-hand side, I should get 0 again. Well, 2 times 6 times 10 to the negative 13th power is 0, so please be aware that that happens. I wish you guys go help T.I. fix that. Turn the page, please. Example 3 says, find the exact value of the cosine of x the cosine of 4x equals the cosine of 2x. Okay, now this one's kind of long, but it's okay. We can do this one. All right. This is almost like a double angle, 2 times 2x. So let's imagine that being the cosine of 2 times 2x, all right? And I'm going to go ahead and pull this one over to the left, minus the cosine of 2x to get this equation in standard form. In other words, solve for 0, okay? And then what I'm going to do is this, all right? We have an identity that says a times the cosine of a times b. That's a double angle. The cosine. This is the double of that. So I'm going to use that double angle identity, and I'm going to write it using the cosine only. All right. And what I'm saying is this. I'll show you the identity I'm going to use. That's this one right here. All right. We got the cosine of 2 times 2x. So I'm going to do 2 times the cosine of 2x. All right. Squared. Minus 1. That's what this first term is equal to, okay? All right, it's kind of like doing a substitution. Okay, all right, and then minus that other cosine of 2x equals 0. Now that also is like a quadratic. Please be aware of that. I'm going to write it in quadratic form so you can see that, okay? Okay, now I'm going to factor it. All right, so I'm going to factor it into two factors. All right, 2 times the cosine of 2x times the cosine of 2x for the first terms, and a 1 here, and the outer product is 2 of these cosines of 2x. The inner product's only 1 of them, so this outer product needs to be negative, and that inner product has to be positive. Okay, all right, so now we've got it factored. We're going to set each factor equal to 0. So 2 times the cosine, oops, I need an S there, of 2x plus 1 equals 0, and the cosine of 2x minus 1 equals 0. Okay, all right. I'm going to subtract 1 and divide by 2. This would give me the cosine of 2x is equal to negative 1/2. Okay, all right. And over here, I'm going to add 1, so the cosine of 2x is equal to 1. All right, now, we're going to go to the unit circle, all right, and we're going to find the values that make this true. Okay, well, I know for this one that 2x, the angle that makes the cosine equal to 1, all right, is equal to 0. All right, and that means that I must, equal to 0. All right, then I need to divide by 2 on each side. That would tell me that x equals 0. Now, it wants us to find the exact values. That s is very important. So that occurs again if you keep adding 2 pi into it. Okay? All right. But wait a minute, this period has changed. This period has changed to 2 pi divided by 2, which is pi. So you really just need to add pi into it. My fault. That's what you need to do. But that just gives you pi in. So x can be equal to pi times any integer n. That's one set of infinitely many. Okay. Now, where on the unit circle is the cosine of an angle equal to negative 1/2? Well, that happens twice. It happens at pi over 3, or excuse me, at 2/3 of pi. It happens at 2/3 of pi, so that means 2x is equal to 2/3 of pi. It also happens, again, all right, 2x is equal to at 4 pi over 3. At 4 pi over 3. So let's solve this. We need to multiply both sides by 1/2. When we do, this one's going to give us x is equal to, all right, the 2's would cancel, so that would be pi over 3. All right, pi over 3, but we got to keep coming back around. The period's changed to pi, so pi n times. Pi times n times. That's what we have to do there. There's another set of infinite solutions. And then from this one, if we multiply both sides by 1/2 to solve for x, that would give us x is equal to, 2 goes 1 time here, 2/3 of pi. All right, so 2 pi over 3 or 2/3 of pi. All right, 2 pi over 3, and we have to keep adding pi in where n is an integer forever, and there are 3 sets of infinitely many solutions for that equation. All right, let's go down to the half angle identities. The sine of theta divided by 2 is equal to plus or minus the square root of 1 minus the cosine of theta divided by 2. The cosine of half an angle, or pi theta divided by 2, is plus or minus the square root of 1 plus the cosine of theta divided by 2. There are 3 tangent formulas for the half angle formulas for the tangent, and the first one is plus or minus the square root of 1 minus the cosine divided by 1 plus the cosine. The second one is 1 minus the cosine divided by the sine. And the third one is the sine divided by 1 plus the cosine. Now, please note that the sine of theta over 2 and cosine of theta over 2 depend on what quadrant that angle theta over 2 lies in. Be aware of that. Okay? Example number 4 says, use the half angle formulas to find the exact value of the cosine of 7 pi over 12. Okay. Well, 7 pi over 12, we want that to be some theta divided by 2. That's what I'm going to write. Okay, 7 pi over 12 needs to be equal to some theta divided by 2. Okay, oops, let's put theta here. And what we do is we multiply each side by 2, all right, and that will tell us what theta is. Theta on the right would be equal to 14 pi over 12. Okay, so there's what theta is. But wait a minute, that reduces to 7 pi over 6. That's theta, okay? All right, so it wants us to find, first of all, the cosine. Well, the cosine of 7 pi over 12, or theta divided by 2, is equal to, that's this formula right here, plus or minus, okay, all right, well, let's talk about theta. Theta is 7 pi over 2. That's more, we need to figure out whether it's plus or minus. 6 pi over 6 is pi at 180, and if you go a little bit pi over 6 more, that's going to put it in the third quadrant, and the cosine there is negative. That's why I'm going to use the negative as opposed to the plus or minus, okay? The square root of 1 plus, we want the cosine of theta. Well, theta is 7 pi over 6, okay, divided by 2. Okay, so the cosine of theta over 2, all right, or if you want the cosine of 7 pi over 2, or over 12, excuse me, is the square root of 1 plus, on the unit circle, what is the cosine of 7 pi over 6? Well, that's negative the square root of 3 over 2, all divided by 2. All right, so this will be equal to, I think we lost our negative. Oh, the cosine's negative, isn't it? Yeah, it should be negative. I'm sorry, negative. And then we want the square root of, excuse me just a moment. Son, you just interrupted my work, and it needs to stop. You hear me? If I come out again, I'm going to swing my belt. Okay, I'm going to imagine this being 2 over 2, so that would be 2 minus the square root of 3 over 2, all divided by 2. I'm going to make that a fraction as well. So this would be equal to the opposite of, all right, the fraction in the numerator times the reciprocal of the one in the denominator, which is 1/2, all right, and that would be equal to the negative of, or the opposite of, 2 minus the square root of 3 over 4. Now you can simplify that a little bit, all right, by taking the square root of 2 minus the square root of 3 and dividing that by the square root of 4, but I don't want to write the square root of 4. The square root of 4 is simply 2. Okay, and there you go. You have simplified that about as simple as you can get it. All right, so let's type that in. All right. Let's find the cosine of alpha y1, 7 pi divided by 12, okay? There's that value. That is the same thing as a negative alpha y1. Take the square root of 2 minus the square root of 3, come out from under there, go down to that denominator and divide that by 2, and you should get the exact same thing. All right, there we go. All right, moving on. Please turn the page. In the next one, it wants us to solve 2 times the sine of theta over 2 is equal to sine of theta. All right? Excuse me. Well, let's start by writing that left-hand side as plus or minus, because I don't know what it's going to be. I don't know where theta is located. Plus or minus 2 times the square root of 1 minus the cosine of theta divided by 2 equals, on that right-hand side, it's still the sine of theta. Now, I don't like having this plus or minus here. That's going to create 2 separate equations. So to get rid of that, I'm going to go ahead and square both sides. Okay? And when I do, all right, that would give me, the plus or minus would go away. The 2 squared would be 4, so 4. That square will undo that square root, okay? So that would give me 4 times 1 minus the cosine of theta over 2, all right, is equal to the sine squared of theta. Now, 4 is divisible by 2. It goes 2 times. So that becomes a 2, and then I can multiply 2 times that numerator, all right? And when I do, that would give me 2 minus 2 times the cosine of theta is equal to, either I'm going to convert everything to sine or cosine, and since that's squared, I got an identity for sine squared. That's 1 minus the cosine squared of theta. And now this is a quadratic equation. I'm going to get it in standard form, okay, by moving everything to the left. When I move this quadratic term to the left, I get the cosine squared of theta, all right, minus that linear term, 2 times the cosine of theta, all right. And then when I move this over, I get plus 1 equals 0, all right. It's now in standard form. I'm going to try to factor it, all right. The quadratic term is the cosine of theta times the cosine of theta. The signs are, to get the 1, it's a 1 times 1. There's no ifs, ands, or buts about that. The signs have to be the same as this, and yes, that's what you get. Or if you want the cosine of theta minus 1 squared. So the cosine of theta minus 1 equals 0, which means the cosine of theta equals 1, and that happens at cosine of theta equals 1 at 0. So the cosine of theta is equal to 0, all right, plus, this has not been altered, so that would be plus 2 pi n, which means that the cosine of theta is basically 2 pi n, where n is any integer. Okay, all right, let's move on. Here are your power-reducing identities, ladies and gentlemen. The sine squared of theta is 1 minus the cosine of 2 theta divided by 2. The cosine squared of theta is 1 plus the cosine of theta, 2 theta divided by 2. The tangent squared of theta is 1 minus the cosine of 2 theta divided by 1 plus the cosine of 2 theta. Number 6 says, rewrite sine to the 4th power of x in terms with no power greater than 1 using the power-reducing identities. All right, let's rewrite the sine of x to the 4th power as the sine squared of x times the sine squared of x, all right? And then we can use this power-reducing formula here to rewrite each of those as 1 minus the cosine of 2x divided by 2, 1 minus the cosine of 2x divided by 2. All right. Now, it wants us to write this with no power greater than 1. Okay. Well, let's go ahead and multiply those numerators. All right, let's do that first. This times this is 1. The outer product is negative cosine of 2x. The inner product is the same, so that's 2 of those. Okay. Plus, when I multiply the cosine of 2x times the cosine of 2x, that's the cosine squared of 2x. And now we have to divide that by 4. All right, so we still have a power greater than 1, that being this power right here. Okay. All right, so what we're going to do next, excuse me, is to rewrite this term right here, cosine squared of 2x, all right? We're going to rewrite that as, and I'm just going to write everything else here the same, cosine of 2x plus, use our cosine formula here. Imagine theta here being 2x. So that means there's going to be a 2x there, which means that's going to be 4x. So that would be 1 plus the cosine of 4x divided by 2, all right? All divided by 4. All right, now, what we can do is this. Let's multiply down below by 1/4. That'll make that denominator 1. We'll do the same up top, okay? All right, so when we do that, okay, all right, let's see what we get here. We could do 1/4. Oh, okay, hold on. Instead of let's multiply by 2. If we multiply by 2, that might be better. Let's multiply by 2. Hold on one second. Yeah, let's multiply everything by 2. That way this 2 and that 2 will cancel. All right, and down below we'll get 8. All right, and 2 times 1 is 2, and 2 times this right here would be, let's see, that would be 2, okay, multiply by 2, that 2 and this 2 are going to cancel. That would give us, if we did that times 2, -4 times the cosine of 2x, okay. All right, and when you multiply this by 2, those are canceled, so that's +1 plus the cosine of 4x, or there we go. Okay, and now these two terms can be combined by and being a constant, and that would give us the cosine of 4x minus 4 times the cosine of 2x, all right, plus 3, all divided by 8. All right, that would work, okay? All right, let's move on. Here are the product to sum identities that you need to learn, okay? I'm not going to read all of them. I'm just going to make sure we see how to work them. You can read them all when you get a chance. Example 7 says, rewrite the product of the cosine of 5x times the sine of 4x as a sum or a difference, okay? All right, and as a sum or a difference, well, if I want a sum or a difference, I don't want any of these because these are not sums and differences. These are products. I want one of these up here, okay? And I've got the product of a cosine and a sine. Cosine, that's this one right here, by the way. So I'm going to use that identity, okay? And I'm going to say that the cosine of alpha, where alpha is 5x, times the sine of beta is equal to 1/2, all right, times the sine of alpha plus beta, all right, minus the sine of alpha minus beta, all right, using that identity. So I've got this left-hand side right here. Alpha is 5x, beta is 4x, so this would be equal to 1/2 times the sine of 5x plus 4x minus the sine, all right, of 5x minus 4x. All right, so that would be equal to 1/2 times the sine of 9x, all right, minus the sine of x. Now, you can distribute if you want. All right, let's do that. You can rewrite that as the sine of 9x divided by 2 minus the sine of x divided by 2, or you could leave it like it is above. Either way, it's going to be fine. Either one of these would be okay. All right, let's move on to number 8. Number 8 says to rewrite the difference of the sine of x and minus the sine of 5x as a product, okay? So as a product, these are products down here. Product of these two, those two are right there, all right? And we got a sine minus a sine. Well, this is a sine minus a sine right here, not a sum of sines or a sum of cosines or a difference of cosines. This is the identity that we want to use, this one right here. That says the sine of alpha, I'm going to use A, minus the sine of beta, all right, alpha is x, beta is 5x, is equal to 2 times the cosine of alpha plus beta divided by 2 times the sine of alpha minus beta divided by 2. Okay. All right, so this would be equal to 2 times the cosine. Remember, our alpha is x, our beta is 5x, so that would be x plus 5x divided by 2 times the sine of our alpha is x, our beta is 5x divided by 2. So this would be equal to 2 times the cosine of, that's 6x divided by 2. 6x divided by 2 is simply 3x. So let's just simplify that to 3x times the sine of x minus 5x is negative 4x, and negative 4x divided by 2a is negative 2x, okay? All right. And by the way, we can go ahead and rewrite that by bringing that sign out in front because the sign of negative alpha is negative the sign of alpha. So we'll just rewrite that. That's one of those odd even identities as negative sine of 2x. All right. And then we can bring that negative out in front, okay, and rewrite that as negative 2 times the cosine of 3x times the sine of 2x. And we have rewritten that as a product. All right, let's turn the page. Example 9, ladies and gentlemen, says, find the exact value of the expression the sine of 75x plus the sine of 195. Okay, all right. Well, that's the sum of sines, all right? And we know that the sine of A plus the sine of B is equal to 2 times the sine of A plus B over 2, the sine of the sum of A and B over 2, all right, times the cosine of A minus B over 2. That's the identity we're going to use here. So this will be equal to 2 times the sine. All right, alpha is 75, beta is 195. All right, so alpha 75, beta is 195. All right, so this will be equal to 2 times the sine. 175 or 195 and 75 is 270. All right, so 270 divided by 2 times the cosine of negative 125, I believe it is, or 120, excuse me, negative 120 divided by 2. That would simplify to 2 times the sine of 135 times the cosine of negative 60 degrees. All right, the cosine of negative 60 degrees is the same thing as the cosine of 60 degrees. So we can rewrite this as 2 times the sine of 135 degrees times the cosine of 60 degrees. Okay, now we know what those values are. We know that from our unit circle that the sine of 135 degrees is the square root of 2 over 2. We also know that the cosine, and this is times, I'll just go and do that, the cosine of 60 degrees is 1/2. Well, that 2 and that 2 cancel. That gives me up top the square root of 2 and down below 2. All right, last problem. We are going to solve the equation. The cosine of 4 theta plus the cosine of 2 theta is equal to 0. Well, that's the sum of 2 cosines. All right, so the cosine of alpha plus the cosine of beta, that is equal to 2 times the cosine of alpha plus beta divided by 2 times, all right, the cosine of A plus the cosine of B is equal to 2 times the cosine of A plus B divided by 2 times the cosine of A minus B divided by 2. That's the identity that we're going to use to solve this problem. Okay, all right, so now, next we're going to rewrite that right-hand side as 2 times A, of course, is 4 theta, B, of course, is 2 theta. All right, so we would do the cosine of 4 theta plus 2 theta divided by 2 times the cosine of 4 theta minus 2 theta divided by 2, which would be equal to 2 times the cosine of 6 theta divided by 2 times the cosine of 2 theta divided by 2. All right, so this first term, or first factor is 2. That second factor is going to be the cosine of 3 theta. And the third factor is the cosine of theta. Okay. All right, so you could go ahead and divide. Oh, and now we're going to solve that. We want it equal to 0, so let's put the 0 over here on the left. All right, and now we're going to divide each side by 2, and that would mean that 0 is equal to the cosine of 3 theta times the cosine of theta. All right, and now we can set each of those factors equal to 0, so the cosine of 3 theta equals 0, and the cosine of theta equals 0. All right, and if we take this one, the cosine is 0, excuse me, at pi over 2 and 3 pi over 2. All right, so 3 theta equals pi over 2, and 3 theta is equal to 3 pi over 2. All right. Also, theta equals pi over 2, and theta equals 3 pi over 2. All right. And now when we solve, we get those right there. Okay. But here we're going to have to multiply each of these two equations by 1/3. Okay. That would give us theta is equal to pi over 6. Oops, excuse me, pi over 6. All right. And this one would give us theta is equal to pi over 2. All right. And now, the thing about these two equations is that the period has changed. The new period for these cosines would be pi over 3. All right. So we're going to take those two. Actually, it would be the new period would be, excuse me, the new period would be, let's see, 2 pi divided by the 3, excuse me, 2/3 of pi. So what we're going to have to do to each of these two is to add 2 pi over 3n. So add 2 pi over 3n. There's one infinite set of solutions right there. Here's another infinite set of solutions. These two right here, the period is still 2 pi, so we would need to take pi over 2 and add 2 pi n. That would give you a third infinite set of solutions. Okay, all right. And then take this one. Theta is equal to 3 pi over 2, and increase that by 2 pi n as well. And there's yet a fourth set of infinite solutions. All right, thank you.